Hello and welcome to m200 online statistics at Cañada College. My name is Lapuz. In this video we will take a look at a homework problem from section 8.5. It says that a simple random sample of 36 men from a normally distributed population results in a standard deviation of 7.1 beats per minute. The normal range of pulse rates of adults is typically given as between 60 to 100 beats per minute. If the range rule of thumb is applied to that normal range, then the result is a standard deviation of 10 beats per minute. Use a sample result with a 0.10 significance level to test the claim that the pulse rates of men have a standard deviation that is equal to 10 beats per minute. So this is our claim that the men have a standard deviation equal to 10 beats per minute. So this is an equal sign, and that's the claim. I think C and D have the equal signs, but the opposite of the equal is a not equal to, and so this is going to be a two-tailed test. We'll select C. Next, they want us to find the test statistic and probably the p-value, and hence make the conclusion. For this, we will use StCr. I already have StCr opened with the basic values given here, and if I look at the stats options here, I have a variance statistics. So this is a standard deviation, but we're going to be interested in looking at the variance. So for example, a variance with one sample with a summary. So this is what we want to work with. And for here, they want the sample variance. We have a sample standard deviation of 7.1. And so I've noticed that we can use a command here. Let's see if I can find it. Data, where we're going to compute an expression. So let's compute the expression. The expression is 7.1 squared, because S is a standard deviation, the variance is S squared. And so let's figure out what that is. Oops. Let's just say compute. And it says new column 7.1 squared added to the data. Here's that number over here. It's 50.41. 50.41 is going to be our sample variance. Where our sample size is 36, and we want to perform the hypothesis test. Now the hypothesis results for standard deviation will be the same as the hypothesis results for the variance. So we're testing for the standard deviation, but we're going to use the variance numbers. Our sigma is 10, and so we want to get sigma squared, which is 10 squared. I don't think I need to use a calculator for that. It's just going to be 100. Our null hypothesis is going to be equals, and remember that our alternative hypothesis turns out to be the not equal to symbol here. And let's take a look at the p-value plot just for the heck of it. We won't really use it, but let's compute. Here are the results. We have the variance, the sample variance, the degrees of freedom is 1 less than the n, and we have our test statistic and our p-value. If we want to take a look at our graph is a two-tailed test, and so we're going to have the test statistics would fall here around a little bit less than 20, bigger than 60 over here. And then the p-value would be the region that's shaded here. Okay, let's go back to this information and put in our test statistic. And we want to round off our test statistic to 3 decimal places. The fourth place is a 5, so we'll add 1 to the 3. And then they want our p-value as well. and we have our p-value from the output, and p-values are usually rounded off to 4 decimal places, so that should be good. Our p-value compared to our significance level, our p-value is 0.01, a significance level is 0.1, and so this is less. Our p-value is less than, so we're going to reject the null hypothesis because our p-value is less than the significance level. And when we reject the null hypothesis, well, it depends on what the claim was. The claim was that it's equal to, so the claim was the null hypothesis. The claim was the null hypothesis, and we rejected the null hypothesis. So there is sufficient evidence to warrant the rejection of the claim, which is the null hypothesis, that the standard deviation for men's pulse is equal to 10 beats per minute. A more effective hypothesis test might have been to say that the standard deviation for men's pulses is less than 10, and that might have been something that we were able to support. So we're saying that it's equal to 10, we're going to reject that, but 7.1 is less than 10. We could have tested if it's less than, and we probably could have supported that claim. But as it stands, there's sufficient evidence to reject the claim that it's equal to, and that should be our answer. Okay, I hope that helps.